Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. In this video, I would like to discuss about subtopic 1.8, binomial coefficients. So here is the objective for this subtopic, where at the end of this lesson, I want everybody must know how to find the binomial coefficients of a term from a binomial series. Alright, so let's start with the introduction first. A binomial expression is simply the sum of two terms such that the basic properties of the combinations C and R also appears in the expansion of the expression x plus y to the power of n. So here we are going to expand x plus y to the power of n. We know if we have x plus y to the power of 2, this is a very easy for us to expand because we just need to x plus y multiply with x plus y. Okay, so this is a very easy for us to expand. But how to expand if we have x plus y to the power of 10, for example? Okay, so it's very hard for us to expand this expression manually. Hence, binomial theorem help us to expand this binomial expression if n is a larger number. So, binomial theorem, let n be an integer such that n greater or equal to 1 if x and y are variables. Then, how to expand x plus y to the power of n is equal to summation. We will start from r equal to 0 until n in a bracket nr multiply with x to the power of n minus r multiply with y to the power of r. So then we just expand this formula summation, that means plus we start from r0 until r equal to n. Okay, where the term nr is actually equal to ncr, or we can use this formula. It's known as a binomial coefficient. Okay, so how to use this one? Okay, just use your calculator. Okay, for better understanding, let's try one example here. Find the expansion of x plus y to the power of 3. Okay, for this expression is actually very easy for us to expand it manually because n equal to 3 only. So we will have x plus y multiply with x plus y multiply with x plus y. So this is how you expand the expression manually. But now we are going to expand by using binomial theorem. Okay, so let's recall what is a binomial theorem. Okay, x plus y to the power of n is equal to summation r equal to 0 until n, and r multiply with x, n minus r, y to the power of r. Okay, so from here, okay, so what is our n? N is equal to 3. That means x plus y to the power of 3 is equal to, from r equal to 0 until 3. Okay, so n is equal to 3, r, x. N is equal to 3 minus r until y, r. Okay, multiply with y, r. Okay, so now let's expand this one. Okay, so the expand I will start with r0, so 3, 0, x to the power of 3 minus 0, y0, plus 3, 1, x to the power of 3 minus 1, y1, plus 3, 2, x to the power of 3 minus 2, y to the power of 1, to the power of 2, plus 3, 3. X to the power of 3 minus 3 multiply with y to the power of 3. Okay, so now how to find the value 3, 0. This one actually is equal to 3C, 0. 3, 1. This one actually is 3C, 1. 3, 2. This one is equal to 3C, 2. And 3, 3 is equal to 3C, 3. Where you can find the coefficient by using your calculator only. Okay, so the numbers here we call it as a coefficient, right? So by using the calculator, the answer that I will have is equal to x to the power of 3 plus 3x squared y plus 3xy squared plus y to the power of 3. Okay, so now let's move to the example number 2. So the first one, what is the coefficient of x plus y 13 in the expansion of x plus y to the power of 25 here? So I will write again the binomial theorem. X plus y to the power of n is equal to nr multiply with x, n minus r multiply with y to the power of r. Okay, so we have x plus y to the power of 25 and we just want to find the coefficient only. What is the coefficient? Okay, coefficient is nr here, or if you have constant value at x or xy, that's one also considered as a constant, as a coefficient. Alright, actually, you are not going to expand everything for just to find the coefficient. Okay, firstly, let's find our R. So how to determine our R? Okay, based on the formula R is at Y. It's easy for us to find the value for R at Y term. Okay, so just compare with this one. So from here, we can get the value for R. R is equal to 30. So without expand everything, okay, by use this formula, so I will have n. Our n is equal to 25. This is our n. So I will have 25 13. Okay, and x is equal to x to the power of 25 minus 13 multiply with y. This is our y to the power of 13. Okay, so from here, what is our coefficient? Okay, since coefficient for x and y is 1 only, so the value that we can have is from here 25 13. So how to calculate this value? Okay, 25 13 is equal to 25c 13, and by using calculator only, so the value is 5200300. So this is about the how to find coefficient for this example. This is a very simple example actually. Alright, so let's move to the example number 2 here. What is the coefficient? Again, we are going to find the coefficient of x12 y 13 in the expansion of 2x minus 3y to the power of 25. Okay, so what is the difference between these two examples? Okay, for this example, we just have x plus y only. But for this example, we have a coefficient for x. Coefficient for x is equal to 2 here, and coefficient for y is equal to minus 3. Okay, and again, we are not going to expand everything. Okay, just compare the formula with our need in the question. So we have r equal to 13, where n is equal to 25. So by using the formula, so I will have 25 13 multiply with, what is our x here? Our x is equal to 2x. So 2x to the power of 25 minus 13. Multiply with, what is our y here? This is y. Y is equal to minus 3y to the power of 13. Okay, so actually I need to find 25 13 multiply with 2x to the power of 12 minus 3y to the power of 13. So what the coefficient. Okay, so coefficient, this one, 25, 13, and then we have here 2. 2 is a coefficient for x. And then so we have 2 to the power of 12. And multiply with, this is minus 3. Minus 3 is the coefficient for y. That means minus 3 to the power of 13. So just use the calculator. So the coefficient for this expansion, I will have minus 3.396 to the multiply with 10 to the power of 16. A very large number. Okay. Alright, continue with example number 3. So now, find the seventh term of x plus y to the power of 11. So before this, the first example, we expand. Second example, we find the coefficient. For this one, how to find the seventh term? Okay. So if we expand the binomial theorem, okay, let's see, I expand with this one, r equal to 0 until n r, x to the power of n minus r multiply with y to the power of r. I will start with n0, x to the power of n, y0, and then plus n1 multiply with x, n minus 1, x minus 1, y1, plus until I have n x to the power of 0, y to the power of n. Okay, so this one, this is we call as a first term. First term r0. So this one, this is a second term. Second term r equal to 1. Okay, for this example, we are going to find 7 term. Okay, term is equal to 7. So what is the r? Okay, r must be less 1 from the term. So 7 minus 1 is equal to 6. Okay, and n equal to 11. So actually, we are not going to expand everything to find the seventh term only. Okay, we just need to find the r. So by using the formula, okay, for seventh term, I will have 11, r is equal to 6, and then x to the power of 11 minus r, 6, multiply with y to the power of r equal to 6. Okay, so just using your calculator, 11c6 is equal to 462, x to the power of 5, y to the power of 6. So this is the answer for 7th term. Alright, we just discussed how to expand binomial expression by using binomial expansion. Actually, we have another one method that can be used to expand the binomial expression. So the method, we call it as a Pascal Triangle. Okay, Blaise Pascal, a French philosopher and a mathematician, discovered the number C and R can be obtained by constructing a triangle array. This array is called Pascal Triangle. Okay, so we are going to make a number, okay, in a triangular shape where the number is a coefficient for our binomial expansion. Okay, coefficient. That's why discover the number C and R. This is our coefficient. Okay, so this is the figure is the binomial. This is a Pascal triangle. Okay, it will start with the first one is a 1. Okay, and then the second layer is 1 and 1. Okay, that means it will start 1 and end with 1. Okay, the third layer. Okay, it will start with 1 and also with 1. So in between 1 and 1, 2. How to get the value of 2 here? So 1 plus 1 is equal to 2. Okay, so how about the fourth layer here? Okay, it will start with 1 and end with 1. So how to get the value in the middle? Okay, so we have 3 here, 3. So actually 1 plus 2 is equal to 3. 2 plus 1 is equal to 3. Okay, so you can construct until n layer. Okay, until how many layer that you want. Okay, then for the first layer, this is for n equal to 0. For the second layer, this is for n is equal to 1. Okay, the third layer n is equal to 2. The fourth layer is for n equal to 3 and so on. Alright, so now, for example 4, expand 3 plus 11x to the power of 3 by using Pascal Triangle. So before this, we know this expression we can expand it manually because n equal to 3 only. Or also we already learned how to expand this one by using a binomial expansion. So now we are going to expand by using Pascal Triangle. So firstly, identify the n. N is equal to 3. Okay, so based on the triangle, okay, so the first layer for n equal to 0, second layer for n equal to 1, the third layer for n equal to 2, and the third layer, this is for n equal to 3. So we will use this third layer. This will be our coefficient. Okay, so how to expand? 3 plus 11x to the power of 3. That's mean coefficient for the first term is 1 plus coefficient for the second term is 3 plus coefficient for the third term is 3 plus coefficient for the last term is equal to 1. So in between, we have 3 here. That's mean 3 to the power of 3, 11x to the power of 0 plus 3 to the power of 2, and then 11x to the power of 1. Okay, and then plus here 3 to the power of 1, 11x to the power of 2, and for the last term is 3 to the power of 0, 11x to the power of 3. So actually we can see here, okay, the power must always equal to 3. 3 plus 0, 3, 2 plus 1, 3, 1 plus 2 is equal to 3, and 0 plus 3 is equal to 3. And also, okay, we must know this is 3, 2, 1, 0. Okay, and for the y term here, for the next term is 0, 1, 2, 3. Okay, so then you just need to expand. Okay, let's expand. 3 to the power of 3 is equal to 27. 27 multiplied with 11. Okay, this is 11 to the power of 0. Okay, so you just have 3 plus 3, 3 to the power of 3 only. That's mean is at 27. Okay, and then for the next one, you will have 297x plus 1089x to the power of 2 plus 1331 to the power x to the power of 3. So this is how you expand your binomial expression by using Pascal triangle. So I hope everybody can are clear with my explanation about the this subtopic. Okay, so all the best guys. Thank you. Assalamualaikum.